Okay, so let's get started. We'll just have people catch up, but today's a really quick day. I'm gonna just review really fast. It's been a weekend, so I just wanna get your brains like a little bit rolling in chemistry. I wanna go over some common mistakes. You'll take your quiz, it's really short. People finish in like less than 10 minutes. So what does that mean? You have a lot of time to work on your Edpuzzle, Unit 5, Part 1. This particular Edpuzzle is pretty long. So I did Unit 4 Edpuzzles. Miss Bailey is doing all the Unit 5 Edpuzzles, and then you'll see me again in Unit 6. So I'm doing like Unit 6, Unit 7, and Unit 8. So you'll see me a lot going forward. All right, but let's get started. So here we go. This is just like a watch me, follow me, make sure you're paying attention to the presentation, and then chat me if you have a question, okay? So we're just all following along right here. Okay, so you saw this type of question on your virtual lab. So it has your picture here. So you're gonna refer to it while answering these questions. Things to remember remember on the left-hand side, I always like to put an L on the left-hand side because on the left-hand side, you have a wavelength that's really long. You can see that this is a very long wavelength, okay? It's like a really tall wavelength. So if you were like to turn it, right, it's tall. That's why it's like a very high number because it's long. It's also very low frequency and low energy. It's very safe. Like you have these waves coming at you, okay? They're not like slow. It's just, it takes a while for one wave to like get through, right? So, you know, radio waves are really safe. Gamma waves are not. So you can see here, everything's really short, right? Wavelength is short. High energy, high frequency, very dangerous. That's why gamma rays can kill you and me, right? So when you answer these questions, you can answer them in like any fashion, right? This one's asking about lower energy. So when you're looking for lower energy, you're comparing gamma and infrared. So here's gamma, here's infrared. So ways you can answer this question. Lower energy, so I'm looking for L side, low, right? So I must be closer to the left-hand side. Or you're thinking low energy, not that dangerous. So which out of the two is less dangerous? Or on the left-hand side, that's gonna be infrared, right? Next one is higher frequency. So when you see this phrase, okay, you're thinking, oh, I have to be on this side, right? Closer to this side. I'm comparing X-ray and green light. So X-ray is here. And some of you are like, but where's green light? Well, green light is a color you can see with your eyes. So must be visible, right? So remember Roy G. Biv, your colors are on this side, right? Under visible, because these are the 7 main colors that you see. So green light is here, this G, so you're comparing visible and X-ray. So which one is higher frequency? It's gonna be X-ray, okay? It like jabs at you more, right? A little bit more dangerous too. Okay, so the next one is a longer wavelength. So this is where a lot of people mess up because the word long throws people off. But when you're thinking of long wavelength, you're thinking about like it's very wide. It's wider, or if you turn it, it's like taller than the other one, right? So you're comparing radio and ultraviolet. So radio is here, right? Radio, ultraviolet's here. So which one is longer? L, left, right? It's going to be your radio, right? This one was really straightforward. Most of you got all of these right, but it's the wavelength that really throws people off. So if you don't have any questions, I'm gonna move on. Okay, this section right here, a lot of people got wrong. And I think it's because you still don't know the definition. So hopefully you looked over it in your notes, but let's go through it really quick. This is asking about the relationship between your vocabulary words. So it's asking like, does it have a direct or indirect relationship? Meaning, do they go in the same direction, okay? Or do they go in opposite directions? So I'm just gonna go through these answers just to see if you know them. Energy and frequency are directly proportional. This should make sense, right? Because if you're thinking about this side, this is high energy and frequency, right? They go together. They're either both high or they're both low, right? L side. So that's how you know they're in the same direction. So if one goes up, here's the keyword up, the other one also has to go up. So same words, same direction. They either both go up or they both go down. So wavelength and frequency, right? This symbol, you might not be familiar with it, but this is wavelength. It's called lambda, it's a Greek symbol. Frequency and wavelength are indirectly proportional. Hopefully you remember this from the notes. In meaning not, right? Not the same direction. So let's think about what this means. When wavelength goes down, right? So when the length goes down, you're talking about something that is really short, okay? It's short, okay? Then this has to go in the opposite direction, because if you are short, so look right here, right? Then the frequency is what? High, right? So when the wavelength is really, really short, it's a small, like think of it as a small height, right? Like 2 feet is shorter than 6 feet, right? So the number is short, the frequency goes up because it's high, right? Opposite directions. The last one is wavelength and energy. Okay, a lot of people actually like to answer this side first, and then they go back and answer this side. So let's try it. Let's look at this side. If the wavelength goes up, right, this means it gets longer. See that L word, longer? That means you're on the left-hand side. You're like talking about like your radio waves, right? Then what happens to the energy? So you're like, the wavelength is really long, like radio, then energy must be very what? Low, because it's very safe, right? Low energy. Look at the direction of the arrows. They're what? Opposites. So if you're looking for an opposite relationship, then what word would you put in here? Indirect, because they do not go in the same direction, okay? A lot of people are messing this up. So like I said, if you don't understand these words at first, do this side first, do the right-hand side first, because most of you can figure it out and then go backwards and fill in the vocabulary word. Okay, but a lot of you messed up here. But the most common mistake was down here, okay? So no questions so far, I see. This section right here, okay? Let's do left side before we do the right side. So I always suggest doing the element first, okay? It's the easiest part, so let's do that side first. You can't use a shortcut here. You have to like manually count the numbers, okay? You cannot use a shortcut. So you have to count this 2, 2, and 4. You have to count the 2, 1, 6, 2, and 5 here. Cannot take shortcuts. So you add total. This is what? 8 electrons. That's oxygen. So that's 2, 1. So add total. 3, 9, 11, 16. That's sulfur. Okay. So this side should be easy, but like half of you missed this. And I don't know why. I don't know where you got your numbers from. So it's the superscripts, right, that you're counting up, and you have to add them all correctly. So I couldn't really tell exactly where you're messing up, but a lot of you miscounted, like half of you miscounted. So make sure you're counting correctly. Now this side should be the easy part, writing the element. This is oxygen, this is sulfur. Then what's the hard part? The hard part is then doing the other side. The other side is determining whether something is in the excited or the ground or excited state. In order to do that, you need to ignore the last part of the configuration. So like, for example, this 2p4 right here, ignore it, okay? You can't determine if something's ground or excited by looking at the last piece of information. So where are we gonna look? We're gonna look at everything before it. See this green part right here? We're going to determine if something's ground or excited state by looking at what comes before the last piece of information. All electrons have to be filled up, right? So S's have to have 2, P's have to have 6, and D's have to have 10, right? So you look, are my S houses full? That one is. Is my S house full here? Yeah, 2 and 2. Then this has to be in ground state. Everyone's home. Nobody went on vacation, right? So same thing here. You ignore the last piece of information because the last piece does not tell you if something's ground or excited. But what will tell you is everything that comes before it. So let's look at the green section right here. Now you do like a count. This S has 2, this S has 1, this P has 6, and this S has 2. Is it ground or is it excited state? Did someone go on vacation? Yes. Where? Here. This shouldn't be a 1. This should be a 2, right? So yeah, this is excited. A little side note is that half of you also misspelled the word excited. So many of you wrote exited like this. I think I fixed it all, but the word is here. So let's spell it correctly, right? Let's put a C in there. We're excited. Ding. All right. So ignoring the last part, you always look at the ones before it and make sure everything's filled up. So like if, for example, if you saw like a 2p5 right here, then you would be like, ooh, that 5's not filled up. Electron went on vacation, it got excited. So always look, right, and pay attention. So the left-hand side and the right-hand side of this box are like completely separate, okay? So that's why you got to do one and then do the other, okay? Like 2 different brain modes, okay? So I think that's it. And no one's asking a question. So here we go. Are we ready to take this quiz?